Episode 1, Outline and Overview. This video series covers the process that I went through to oversee the construction of a timber-frame home on a Minnesota lake. I acted as the general contractor and foreman for the project. Other than the timber frame itself, I accomplished all the engineering and design of the interior of the home. My wife and I then did 90% of the labor for the construction, only hiring contractors when necessary or expedient. Disclaimer 1. We did not design or manufacture the timber frame ribs themselves, so this is not a video series on how to process raw lumber into timber frame members with mortises, tenons, and oak dowels. Disclaimer 2. I understand by posting this video that I open myself up to both praise and criticism. This series is not comprehensive legal guidance on how to build a home. This series is simply my research, design, and experience in building a home. I may have over-engineered in some areas, and there are other areas where a licensed contractor may have done things differently. If you're going to undertake a project of this magnitude, ensure that you have knowledge of local and national codes, and that you permit, license, and construct in a legal and safe manner. Caution: acquire and use your personal protective equipment, PPE. This should include, at a minimum, safety glasses, hearing protection, gloves, fall protection, steel-toed boots, climbing harness, and ropes. Some callouts to businesses that were very helpful in my construction: Blue Ox Timber Frames, Boise Cascade, Builder's First Source, Intercept, Lowe's, PexUniverse.com, and SupplyHouse.com. This video has 43 episodes. Each episode can be accessed in order in my YouTube playlist, Be Your Own Contractor Foreman. Each episode will have notes and links in the descriptions showing sources for code, regulations, and guidance that I followed during design and construction. The episodes are presented in the order that the items were accomplished during the design and build process. The episodes are as follows. Episode 2, Project Management. We required a project management tool that used a Gantt chart. A Gantt chart is a bar chart that illustrates a project schedule. It was designed and popularized by Henry Gantt around the year 1913. Modern Gantt charts also show the dependency relationships between activities and the current schedule status. It will have timelines, critical paths, and dependencies. After much research on the available products, we settled on a product produced by the company contractorforeman.com. In addition to the Gantt chart, the Contractor Foreman management allows for scheduling, tasking, budgeting, contact information, and tracking of all receipts for tax basis calculations. It would be nearly impossible to run a project of this magnitude without a project management tool like this. As you can see here, I have the schedule Gantt chart pulled up. On the left are all of the tasks that I have identified. I have set time lengths for each task and have also connected the tasks for dependencies. I have also placed milestones in the chart. As we think of more tasks that need to be done, we simply add them in the left column in the appropriate place. If a task takes longer than I have allocated, I simply modify that one task. For example, I can change it from a 1-week task to a 2-week task. When I do this, every subsequent task that was dependent on this primary task will also be slipped by 1 week. This is very handy for scheduling subcontractors and for material delivery. Episode 3, Licensing and Insurance. Permitting. Land alteration permit, building permit, and electrical permit. That's a permit to self-wire your house in Minnesota. Blueprints and plans. Not required to be engineered approved in this Minnesota county. Caveat emptor. Minnesota electrical permit. The homeowner is signing an affidavit and declaring that they own and occupy the residence and that they will personally perform all of the electrical work, including the planning and laying out of the electrical work. The homeowner is exempt from having to possess a personal electrical license. You can apply online, and the link is below. You must comply with the code specified at the time of your application. If you renew your application in future years, the original application code still applies. Insurance. It can be problematic to get insurance for a project that you are building yourself. During construction, you need a policy for loss or damage due to theft, fire, tornadoes, etc. I found that during construction I was able to get a builder's insurance policy from my normal insurance, USAA. Later, when I went to convert this normal property insurance, I needed to go with a local company. The policy needs to have dwelling, medical, and liability at the minimum. I went with 100% replacement costs. My homeowner policy annual premium for a $1 million policy was just over $800 per year. That gave me $700,000 of dwelling and property and $300,000 of liability. You shouldn't need to get workman's comp for anyone you bring onto the property. Just make sure that incoming workers are bonded and insured. You don't want to lose your construction project to an injury lawsuit. Episode 4, Design, Blueprints and Interior Room Layout. My wife had decided on a Timberframe style home. I had no idea what that was. Looking at some of the common types of home building styles, you have frame, where you build external and internal walls of 2x6 and 2x4 lumber, post and beam, where you take large timbers for the frame of the structure, butt them against each other and connect them with steel plates and bolts, or timber frame. You take large timbers and cut mortise and tenon, securing with oak dowels. You can see here how the tenon inserts into the mortise and then is secured with oak dowels. My wife worked with a designer to get the basic layout of the timber frame and the layout of each of the 3 floors. The timber frame would only be in the center section, encompassing the kitchen and great room with a balcony above the kitchen. The side rooms on the main floor and the upper floor and the basement were standard construction, unrelated to the center timber frame. The design was an iterative process for my wife, as she bounced her ideas off the designer. The designer would respond with what was normal, what was possible, and what wouldn't probably work. In addition, my wife called other folks who had built similar timber frames and asked how their process had been. She also asked what they would have done differently. One of the big items was the size of the side rooms outside of the timber frame center. The original design was for 12-foot spacing, left to right, between the walls. The feedback she received was that 12 feet was not enough, and that with a bed and dresser in those rooms, there wasn't enough spacing to get around. So, our design for these side rooms changed to 14 feet spacing to take this into account. Based on the location of a tree and our proposed entry to the house, we even flipped the entire structure left-right at one point, so as to better meet our needs. Based on the proposed layouts from the designer, I put together a set of designs that I needed for construction. Believe it or not, I did all of these in Microsoft Word. It's easy for me to work with. The design needed to include the size and layout of the proposed kitchen cabinets. My wife used a cabinet designer at Home Depot and then ordered all of our cabinets from them. This is what they came up with. Episode 5, Design, Timberframe. Once the design had been completed, the designer sent them over to Blue Ox, a nearby timberframe manufacturer. They worked up the technical designs to include all loads and stresses on the members. Episode 6, Design. Outer walls, roof. SIPS. Once we had the basic design and the timber frame designed, we now needed to design the outer rooms. These rooms would have trusses that could hold the load while only being supported at the ends. These trusses would be attic trusses, which allow for an upstairs room in the center of the truss. I contracted with a local truss business who did the stress engineering design and manufacture of the attic trusses. For the foundation, we began talking with the foundation contractor about our layout and requirements. Basement versus crawl space. At first, we thought that perhaps just a crawl space below the timber frame would be appropriate. The contractor, however, convinced us that a full basement would be far better for us for the following reasons. Not much more cost to put up slightly higher walls on the crawl space. Great storage and extra room in the house. Great place to have your utility room. Lastly, and perhaps most important, a great tornado shelter. Sunrooms versus screened-in porches. Our design initially had 2 screened-in porches facing the lake. The contractor recommended that we run the foundation to the outside of this space. We would result in a bigger house, no additional cost, same lineal feet of concrete, and he said, open a window if you want a new sunroom, to feel like a screened-in porch. Outer walls and roof, SIPS versus traditional framing. Due to the high insulation R value and ease of construction, we elected to have the outer walls and roof constructed from structural insulated panels, SIPS. We contracted with Intercept of Waterton, South Dakota for the manufacture of the SIPS. Price. SIPS are quite a bit more expensive than 2x6 framing. 2 to 3 times more expensive. R values. A 6.5-inch wall, a SIP, gives an R21. Traditional fiberglass is only an R of 13, so it's 50% greater in the R value for the 6.5-inch wall. For a 12-inch ceiling, a SIP gives an R of 48, and a fiberglass traditional for 12-inch ceilings, if your ceilings are that thick, gives an R of 50. So the wall R value is quite a bit higher in the SIP. Part of this has to do with thermal bridging in traditional frame construction. This is the condition where energy travels through the non-insulated studs, disrupting the insulation layer and causing heat loss. Ease in design of construction. The exterior design of the house is provided to the SIP manufacturer. They build the SIP, and the construction phase is then simply putting the SIPs into place. Each panel is custom made at the factory, numbered, and then installed. You can see how each panel is numbered in this design photo. SIPs are manufactured with electrical channels preformed in them. These channels are used for electrical wires. Boxes for lights, outlets, and switches are field cut where needed, giving channel access.